Okay, so in this third video, in the mole conversion series, we're going to be looking at changing atoms into grams or grams into atoms. We could actually interchange atoms for molecules or formula units, and we'll actually do that as an example. So we need to know this conversion, or we need to have it memorized, which would be great. We need a periodic table this time because we're going to be dealing with grams from the molar mass of each of the elements, and then we need a calculator as well. Boom. So now let's come up with a problem. Let's do how many Okay, so in this example, we're going to go and calculate how many atoms are in that many grams of salt. And really, I should have been more specific and said sodium chloride, which I'm saying now. Okay, so the first step here is to calculate the mass of 1 mole of this. So sodium is 22.99. Chlorine is that many grams. So these numbers came straight from the periodic table. That's an equal sign. So 1 mole of sodium atoms would weigh that. 1 mole of chlorine atoms would weigh that. The ratio is only 1 to 1, but we've got to pay attention to any subscripts that are there or not there. If you add those up, you get 4. Okay, so you get 58.44 grams of sodium chloride is equal to the mass of 1 mole. So now that we know that, and we know this, we can answer this problem. So we're going to put 100 grams here. So out of either of these conversions, which one can I use first? Well, I know that I've got grams here and I've got grams here, so I'm going to put that many grams down at the bottom, so then I can cancel out grams. I know that 1 mole is equal to a certain number of atoms. Ooh, problem. We're actually going to be dealing with formula units. So hopefully you were all screaming at me, F you, because sodium chloride is a metal and non-metal, so we use formula units for ionic substances like that. So thank you for that. So instead of atoms, it should have been formula units. But anyway, we caught it. Suppose I should have edited that out. Anyway, so grams cancel, moles cancel. Now we've got to do this multiplied by 1 multiplied by this, and then divide by 58.44. So we're going to do 100 times... Okay, so we get that many FUs, 1.03 times 10 to the 24. Alrighty, so let's do another example. This time let's choose a molecule, just to mix it up. I'm going to erase that. And erase that. This time we'll do the opposite conversion. So this time we'll have, we want to look at how many atoms or molecules or formula units would be in a certain number of grams. We just did that. No, we're going to do how many, we're going to change this, atoms into grams. So So now we have a number of molecules and we're going to change that into a number of grams, and it's carbon dioxide this time. So step one is to calculate the mass of 1 mole of carbon dioxide. So carbon is 12.01 grams, 2 oxygens, that would give us 16 grams times 2, so that's going to be 44.01. So that's the mass of 1 mole of CO2. We know that conversion, we know this conversion, we know what we're converting, so we can do this. So that many molecules. So molecules, remember, non-metal and non-metal bonded together. So we can change molecules into 1 mole. And then, last but not least, let's change 1 mole into a certain number of grams. So, this would give us that times 44.01. Okay. I realised something that I should have mentioned earlier perhaps, but on the TI calculators you need to put these values in parentheses, otherwise you'll get a weird number. So the solution would be, oh, let's just do it, even though I'm running out of time. That many grams. And that's it.